work is to slowly get you guys ready for working with formulas. And when we work with formulas, the idea behind having a formula is so that we don't have to reinvent the math every single time there's a problem to be solved. The formulas get used over and over and over because they're a pattern that describes something. So whether it's something as simple as a formula for the area of a rectangle, which is just length times width, or if it's a formula for calculating how much you owe for sales tax when you buy something, and that formula gets programmed into some type of a cash register, or if it's a program that tells a motor how to mix the air and the gasoline to be able to operate efficiently, and that formula is in the computer of a car or a belt motor or something like that. These are things that the calculation gets to happen very quickly, over and over and over. And what we're doing with you here is we're showing you basically substitution so that we can work with formulas. And then once we learn a little bit about formulas, then we're going to show you a little bit about spreadsheets, which is going to happen later on. So that's how all of these things fit together. So when you take a look at your homework and tell me if you have any questions from it. As you can see, lots of formulas. Over and over and over. I think I wanted you to work just up to 11, right?
Yeah. Yeah.
There are a couple more questions, but we need to sign off. You get there? So,
I left my stuff in my locker.
in your locker?
In my locker.
Wow, well, that was super fun. I've never seen somebody with the same color one as own. There's a dents in it too, just like this one. But see, I have two stickers on here. Homework?
Wait, so,
Yeah.
so, wait, so,
Square root?
square root. So once we figured out, like, the thing, like the answer for it, do we put the square root and answer for it, or do we just put the answer?
Are you asking about number 11?
Yeah.
Yeah, number 11. We have the square root of d divided by 2, and what do they want d to be equal to? 8?
Yeah.
Okay. So if your work looks like this, and I looked at a lot of your work, a lot of you just have answers. That's not going to fly when it comes quiz time. I need to see the work. So if they say d is equal to 8, then we would rewrite it like this. And then we might simplify. We've got to do the fraction inside of the radical first. So what's 8 divided by 2? 4. And then, yes, to simplify, we want to remove as many symbols as possible, so get rid of the square root sign. What does this equal? 2.
Okay.
Yeah, so carry it all the way out to the end. Okay, more?
No.
No. What did you guys write for number 6?
Okay.
Yeah, 6A.
X times 4 plus T times 2.
Is there another way to write it?
Yeah.
TJ?
S times 4 plus 2t.
Oh, yeah?
Could be 4S plus 2T.
Yeah, that's how I'd like to see it if we could. Put your coefficient, the multiplier, put that in front of the variables. So 4s plus 2t or 2t plus 4s, it's fine. If you wanna stay ahead of the game, alphabetical order is when things start getting more complex, alphabetical order is always safe. S comes before T.
Well, that is an alphabetical order.
Yes, it is. So what is the perimeter? Now, that's perimeter. So if we were gonna write an equation, we might write it like this. P is equal to. But you didn't need to do that, but that's how we would write it as an equation. So then, what is the perimeter if S is 25 and P is 14? We're just gonna substitute in. What's 4 times 25? 100. What's 2 times 14? So that's 128. Yeah, that's all. And, oh, they're inches, aren't they?
Yeah.
Yeah, so it might be nice to do that. So would you like to ask about anything? No? Okay, do you have your graphing calculators? Good. Do you have your homework? 1 through 11, yours I didn't see because you didn't have your stuff open when I walked around. And I didn't walk over here either. Do you have 1 through 11? No?
I might have done it in my science one because we had science homework.
Okay. So remember that if you don't have it, your word is not good enough for a grade. You gotta show me your work, okay? So make sure you bring it back to me within a day. Or take a picture of it and email it to me. I'm good with that as well.
And we'll still get like points.
Get half credit for late, for 1 day. And
What
then,
if we show it to you today?
beginning of the hour is on time. Yeah. Okay. So 2-4, expressions and formulas. So the 2 vocabulary words are equation and formula. So an equation needs an equal sign. It's that simple. And a formula is going to have more than one variable. That's really the difference between some of these equations that we write, like an algebraic equation that has, like x squared plus 10 or something like that. That's algebraic. But a formula has multiple variables. And the variables, each variable can be any different input value or many different input values. So if we look at the first example that they give and how they use this, it says B is the number of beef kebabs, and C is the number of corn kebabs. No, the number of corn on the cobs. I was gonna say corn kebabs, that would be kind of different. So B is the number of beef kebabs, C is the number of corn on the cobs, and W is the number of watermelon slices. So it looks like they're putting together food. And they give us an equation here, or a formula, I should say, which is 2.25 times B plus 0.75 times C plus 0.5 times W. So what do you think the numbers in front of the letters stand for? What do you think the 2.25 is representing?
How many pounds of beef?
How many pounds of beef? Are you gonna eat 2 1/4 pounds of beef?
Maybe it's a party.
The money
Maybe.
it costs?
Yeah, maybe the money it costs, huh?
That'd
75.
be pretty cheap.
Yeah, 2 1/4 for a beef kebab
No.
for one. That'd be pretty cheap, wouldn't it?
Well, but
Maybe it's down south.
Yeah, maybe it's down south. Maybe it's down south a few years ago. But I think that this is This is meant to be money. This is $2.25 for a beef kebab, 75 cents for a corn on the cob, and 50 cents for a watermelon slice. And what would B, C, and W possibly stand for? Yes.
Beef.
Variable for how much or how many of these. So if we all went in together as a class, and you got one of these for each of us, how many will we have to buy?
23.
Like 23 or something like that if we were all here? And then, how many of these?
23.
If we've got one for each, we put 23 in here, and if we got watermelon for each, that'd be like putting 23 in there, and then we can multiply together and come up with the cost.
You could just buy a whole watermelon.
You just buy a whole watermelon, yeah.
Maybe 2.
So, but if just you walked up and you said, well, geez, I wanna eat 2 of these, and 3 of these, and then 1 of those at the end, that would be substituting values that are to be different for each of these, which the formula is showing can happen, because B, C, and W are different numbers. So what they would like us to do is they'd like us to evaluate when B is equal to 2, C is 3, and W is 1. So this is really no different than what we did in the last lesson, is it? All we have to do is put in 2.25 times 2, substitute the 3 in the place, and rewrite this. So why don't you grab your graphing calculator. Where's yours?
I left it here, but it's not on the shelf.
You left it there, but it's not on the shelf. Every one of my students that comes to this room has their own graphing calculator. You sure? Did you look in another box? Did you check in your own stuff? I bet you took it with. No?
No, I'm pretty sure I did.
I feel comfortable that you did. I don't think anyone's gonna take one from in here. Even these don't go disappearing. Use this one, make sure you give it back to me at the end of the hour, please. And then go searching for yours. Make that a priority today. Okay, so here's what I'd like to do. Go to lists. Who remembers how to get there? Stack. Edit. You
This one
clear
doesn't-
out lists 1, 2, and 3 if they're not already clear,
There's no
and 4.
batteries.
Remember how to clear lots of data at one time?
Okay.
If you go and you actually highlight L1 or L2 and hit clear and enter. So you use your arrows to go up and actually highlight L whatever. Hit clear, enter, the whole thing is gone.
This one doesn't have batteries.
Doesn't have batteries? Or is it ripped off? Let's see what I have. Okay, then what I'd like you to do is I'd like you to, in L1, I'd like you to put this number 2. And then I'd like you to go over to L2 and put in a 3, and L3 put in a 1. So in L1, let me write it this way. In L1, you're going to put this number 2. In L2, you're going to put the number 3. And in L3, you're going to put the number 1. And then how many of us are in here today? Look around. How many of you are here? Miss Laura's back there.
Do we count you?
Sure. Are there 19? Okay, so if there are 19, do this. Put 19, 19, and 19
Where?
in L1, L2, and L3. Okay, then do this. If, think about how many people are in your house. And then ask yourself, if we were gonna go and buy beef kebabs, how many would we buy? Put a number there. How many corns would you buy? And how many watermelons would you buy? Put that into L1, L2, and L3, so that we have multiple sets of input data. We have multiple sets of how many beef kebabs might get bought, corn on the cob, and watermelon might get bought. And if you're not keeping up with me, call me over to help you.
So we'd put these numbers in.
Watermelon? Oh.
Well, for the third number down, you can choose how many in your family you think you would buy if you're gonna buy beef kebabs, corn, and watermelon.
For the third one? Oh, for the, so,
Where's the 19, that's right, okay. The first one's gotta be, the first row of L1, L2, L3 needs to be 2, 3, and 1. And then the second row would be 19, 19, and 19. And then the third row would be how many would be in your family.
wait, two,
Wait.
three, and one,
Okay.
in that order?
Yes.
I'm confused.
Okay. So if I was taking this data here, let me just draw it over here a little bit more, less cluttered. If in my graphing calculator I have L1, L2, and L3. In the first L1 I would have a 2, and then I would have a count of 3, and then a count of 1. That's what my calculator looks like. And then this class would be 19, 19, and 19. If we bought 19 kebabs, this is going to represent the number of corn on the cob, and this will represent the number of watermelon. Then your family here, and what I did is I just said, well, Joan and I went, we each get 2 kebabs. So that would be a total of 4. And we each get 2 corn on the cob. Heck, she'd probably take 3, so I'll put 5 down for. If I eat 2 and she eats 3, then that's a total of 5 corn on the cobs, and then just 2 watermelon.
You guys don't?
And I'd like you to do that for your family, what you think, so you have different numbers than me.
And how many watermelons?
So now that,
These watermelon slices.
I don't know,
Look at the picture.
like in the picture. Put down more is always better, right, if it's good watermelon.
20.
Okay, so now,
Watermelon for the dog.
are we good? Yes.
Yeah.
How do I get rid of something?
It goes, yeah, it's been doing that. Ooh. Now I'm gonna go over. And then hit 19 and then enter. Yeah, you have to hit enter after you put a number in. You can't use the arrows to move away. Okay, so are we good to go?
Yeah.
Okay, so here's what we're gonna do. Now we're gonna figure out what this all costs if these are the prices. So listen carefully. If you were doing this right, if you were gonna do this, for example, on paper, you would take 2.25 times 2 plus 0.75 times 3 plus 0.5 times 1. And you could do that on a calculator. You could just calculate that way. Add them all up, and that's your total cost. So what we're going to do is in L4, we are going to have the calculator do that for all of these combinations. So you need to go and highlight L4, move your arrows till L4 is highlighted. And then you're going to type 2.25, and then you're going to do times. And then here's the tricky part, you have to choose L1,
Which is
which is the
second
Yep,
one.
the second, and then the key 1. And then you're gonna do plus
Oh,
0.75 times L2 plus 0.5 times L3. And you do not hit the equal sign. You just hit enter and it will do all the calculations at one time.
Okay.
And then L4 will be a big long list of how much it costs.
Yeah, good.
You have it done? Where's L4?
I'm not gonna tell that first though, like.
So use your arrows to move over to L4. Well, you have extra numbers in here, we can't. Well, go away, here, that's fine, hit clear, enter. There, keep it highlighted, move up. There you go, now enter what I have there in black, 2.25 times.
Well, that's not have two.
How we doing?
Hi. That,
What have you done so far?
yep, no, then last time.
So now you're gonna go to L4. Don't do it first, don't do it. So now you're in L4, highlight L4.
Put some water down and go in.
The arrow. Use the arrow to go up.
Oh.
Hit enter.
So unreliable. I know.
Now go up with the arrow.
then what do we hit?
Now, 2.25 times L1.
Phoenix. What do we hit? After we get cleaned up? What do we hit after we got all the numbers?
Okay, go to staff. And staff top. Staff is right there. First function.
Wait, no, we're supposed to type in, that's what you said.
That's what I did.
So there, you gotta clear everything. Go up. Stop. Clear. Enter. And then go. Clear.
It's age appropriate for everyone.
And then you go up again, move over to L1. Clear. I'll put your numbers in here, I have them. I'll do all that. You got it?
Sweet.
They don't know when now.
So you have 0, 0, 0, 1. Okay, so if you go up here and you hit
Wait,
DBL,
Riley, is that the whole equation?
set this thing down, so it's all. I'll move over and go up to L4 and put in the total. Do you have it in? So now go up arrow.
It won't let me do that.
No. How are we doing here? Okay, but you need to have L1 highlighted before you do all of this work. There you go. So now go back up. Move L4. L4. Now I do 2.25. Do you have it? Do you have it?
Yeah.
All right. How about up here?
Every
So now
time.
you have L4,
Yes.
so 2.25.
It's the third time I did it.
Oh, okay, plus. Okay. Times L3.
Wait, no, we would have to put the others.
25 times L3. Second 3. 0.5. And then L3. Second L3. Now hit enter. There. Calculate. Do you have it? TJ, yes? Clover? You have it?
Wait,
Brooklyn? Yeah, then 2.25, et cetera. And then all you do is hit enter when you're done. So you have 0.5, but that has to be not 12 times. And then, once you clear that whole thing, start from scratch. Just hit clear. Now, 2.25 times. So, you have it. Yeah.
It's awesome.
And L1 plus Well, you're doing 2.25 plus. Alright, so hit here. Okay, 2.25. You can just set this down. It's not a cell phone. You have to use your fingers instead of, so 2.25 times, second, 1. Second, no, that's something completely different.
Oh, I've been hitting 7.
Yeah, I don't know what you're doing then. It's gotta be second, and then the 1. So, you have it. Did you get it? You guys are all good back there now? Yes?
Yeah.
You got it through?
Yeah, I got it.
Okay, now the one thing about this, if you went back to your lists and you added another set of numbers, it doesn't automatically give you a value for L4. You would have to go and tell it to do the work all over again. So what did you get in L4 column, I'm sorry, L4 row 1?
7.25.
725?
Yep.
And what did you get for the second?
66.5.
And then your numbers here are probably all different, aren't they?
Yeah.
Yep.
Okay, so when we do this kind of work on the graphing calculator, this is a spreadsheet. So I don't know if you guys have used Excel or Google Sheets, and you've used equations where you start with the equals key, and then you pick a cell and multiply it or add it or do some kind of math. Have you done any of that work yet?
Yes.
Wait, what? No, I don't
We
Oh,
have
and
Mr. Baumgartner's.
You have? You've used spreadsheets with Mr. Baumgartner?
Yeah. We have, remember?
Just a little bit, we
Just a
don't.
bit, not a
Okay,
lot.
maybe you put numbers in and then made graphs.
Yeah,
Yeah.
that's what we've done.
Yeah, but you probably haven't used the spreadsheet the way the spreadsheet's designed. Spreadsheets are designed to take lots and lots of numbers and data
Yeah.
and do all kinds of math with them.
I know it's very.
They do math that you don't understand for many, many years to come. They're extremely complex programs. Your Google Sheets or your Microsoft Excel is the most powerful thing on your computer. No, it is. It is the most powerful thing on your computer by far.
What?
So like,
Sheets and Excel are the most powerful programs on your computer.
wouldn't it be like the computer, because that's what's powering everything else?
Yeah, but the computer doesn't do anything unless you tell it to do something, and you need a program to be able to tell it.
But you still need that thing to use like the sheet or Excel. So technically,
Wait.
whatever comes before it to make it happen is more powerful.
Okay, so I'm arguing it's the most powerful program on your computer, by far.
Google. I mean, Chrome.
No,
I'm sorry, it's not.
because the Google has servers
I've been on
itself.
it, I've been on them quite a bit, because with these spreadsheets, you can tell the computer to do what you want it to do. If all you're doing on the internet is, you're looking at the internet, you're reading what somebody else has told the computer to do. And you have no control over that whatsoever.
Wait, what about traffic?
So without arguing with that one for too long, think about that for a minute. When you're on the internet looking at websites or using apps, you are doing what somebody else has told the computer to do. You're reading that. But if you use a spreadsheet like this right here, you're telling what the rules are. So spreadsheets are incredibly powerful. Let's go forward. Formulas. So an equation needs an equal sign. A formula is going to have more than one variable which is involved. And when we use formulas, it's important to include units, because units can help to tell us whether we're using a formula correctly or not. So for example, they start out with something familiar or something simple that you are familiar with, and that's the first example. And they have a rectangle where they say that the width is equal to 6 inches and the length is equal to 3 feet. And they want us to use the area formula. So what is the area formula for a rectangle?
It's, I know it's square, but what's times,
Yes?
what's times length divided by 2?
That would be a triangle.
I thought you asked for triangle.
Did I say triangle or did I say rectangle?
Rectangle.
I think I said rectangle.
Oh, I heard triangle, my bad.
Okay, that's fine.
Uh,
So it's just gonna be length times width, but we don't need to divide by two. And typically we use lowercase l, and we use lowercase w. And for area, we use capital A, that's pretty standard. So when we use formulas, we have to take a look at whether we're using upper or lowercase. Because an uppercase L stands for something completely different, as does an uppercase W, as does a lowercase a. So from this right here, we have a length of 6 inches and we have a width of 6 and a length of 3 feet, but we don't have the same units.
I thought this said bin.
What's that?
I thought
Oh.
it said bin.
Yeah. Here's 6 inches, how's that?
Better.
Yeah,
So what would you rather do, change the inches to feet or the feet to inches?
feet to inches.
Okay, I heard feet to inches,
Makes
so
sense. I think so.
if we do that, how many inches is this?
3.
36.
Oh,
3 feet, 36 inches. So come down here to your formula, A equals 36, include your inches. And here it's a little more convenient to use parentheses for multiplication. Because with the dot after the inches and such, things start getting mixed up when we have dots in multiplication. So what is 6 times 36? Okay, 3 times 6 equals?
36.
Equals 18.
Oh.
So 30 times 6 is going to be 180. And that gets added to 6 times 6.
Wait, it's a 6 times 36.
216, yeah. So then with the units, in the back room of the room. So with the units, it's inches multiplied by inches.
Inches squared.
That's going to be inches to the second power, yes, squared.
Wait, so what was 18 under that again?
Okay, so when we took 36
Oh,
multiplied by 6,
6. Okay.
if we did this in our head, this 3 times 6 is 18, but times 10 is 180.
I see.
And then we're going to add that to 6 times 6, which is 36.
Okay.
So that's where we're doing this in your head, without having to take the time to punch on the calculator to make things more efficient. Okay, last example. They give a square within a square. So rather than just doing area and things, because you've been doing this for a while, we'll throw a twist into it. So it says the area of the shaded region at the right can be found using this formula. Here's the picture. So they have a shaded square on the outside here with a clear square in the center. The larger square is 1.5 inches. The smaller is 0.75 inches. So this is all on the top of page 93. And what they're saying is that the area of the shaded region on the outside is going to be like taking the largest square and subtracting the smaller square, which is in the middle. Kind of makes sense. So they write the formula like this. They say that the area of the shaded region is going to be equal to, and they use a capital S, and that is going to be this side here, 1.5 inches. So this square is length times width, but because it's a square, length and width are the same, so all we have to do is square 1.5, because it becomes 1.5 times 1.5. And then we're going to subtract the smaller square. So I'm going to put a little mark through my little s so that you know that it's a lowercase s.
Oh, that's what that is?
And that's going to be to the second power. So that's this length here, 0.75. So if this is the formula that we're using, all we have to do is substitute the values in. Yeah, you could probably make them larger and smaller on your paper, but on the board up there, it's hard for me to make sure that they look large and small. Sometimes people will put a bar over the top of a letter to ensure that it looks like a lowercase s as well. Okay, so we have to take 1.5 times 1.5. Can you do that in your head? What's 15 times 15?
15 squared.
Right, what is 15 squared?
Probably a calculator.
Well, you know, that's fine, but
He asked if you could do it in your
I'm
head.
asking if you can do it in your head. I know you can all do it in the calculator, but if you start learning to do math in your head, your math will go faster than reaching for a calculator and having the code switch into,
220.
excuse me, you're interrupting me. That's twice. But if you go from thinking about this and having to use a calculator, you have to code switch to get onto the calculator. And then you gotta code switch your brain back to writing on paper, which slows you down. But if you can be keeping it all happening in your head without having to use your hands, your work will slowly get faster. So that's why I encourage you to try to do mental math. So 15 times 15, it's 225. Did you do that in your head? See, what you can do is you can do it like this. 10 times 15 is 150. And because 5 is half of 10, the answer of 5 times 15 is going to be half of 150, which is 75. So here, those are the digits. Where would you put the decimal point, which would be making sense of 1.5 times 1.5?
22.5.
Between the 2 and the 2. So your answer is between 2 and 3. So that's going to be inches squared, and then 0.75 times 0.75. I know. What's 0.75 times 0.75? That one you might use your calculator for. It's going to be the same as 9/16. What is it? What is it? 52625? Ooh, that's an ugly one.
No, 5625.
5625, okay. Thanks. So once you do that subtraction, you can do that one on your own. So that's the basics of doing these. I'm going to ask you to check my webpage for the homework. It's on there. It's been on there for a couple of weeks, but I want to make sure you guys are going to that Google Doc as well. Look for yours, okay?
Don't sit in the front row till I drop my view.
Thank you, TJ. You too.